Now in its 24th year, the Philippine Mathematical Olympiad is the oldest and most prestigious nationwide mathematics competition among high school students. After its trial run in 1984, it was officially launched in 1986 and has been held annually since 2007. The country's contestants to the International Mathematical Olympiad are chosen from the top students who compete in the Philippine Mathematical Olympiad. The PMO is a project of the Mathematical Society of the Philippines and the Department of Science and Technology Science Education Institute.
Hello everybody, my name is Issam Wang, a past contestant of the Philippine Mathematical Olympiad, welcoming you to another episode in the PMO video series. So for today, we have algebraic manipulation. So as the word suggests, we're going to do algebra, we're going to manipulate via algebra. And throughout this episode, we're going to follow the theme, we're not asked to always find x or any other variable for that matter. So some questions, like the ones I'm going to show you, you don't have to solve for the unknown. For example, in the first one, if x minus y equals 4 and x squared plus y squared equals 5, find the value of x cubed minus y cubed. Now, obviously, I could solve for x and y here because, well, I do have two equations, the first one and the second one, that's going to allow me to solve for x and y, but we're going to approach this differently. What we're going to do is take a look at x cubed minus y cubed. We know that's factorable because it's the difference of two cubes. So we know that x cubed minus y cubed can be factored as x minus y times x squared plus xy plus y squared. Now, taking a look at the given, we do have x minus y to be 4 and x squared plus y squared to be 5. So this part is okay. The x squared and the y squared here is okay. We do have an issue though. We don't know what xy is. All right, that's no problem. We should be able to get xy just being creative in our solution. That's what algebraic manipulation is about. So we do have two equations, and well, we just had to find a creative way to get xy. Now, some of you guys would probably know that if I'm going to square the first one, if I'm going to square x minus y equals 4, I'll get x squared minus 2xy plus y squared is equal to 16. Again, this might be obvious to some, but try to play around with the given. Eventually, we should be able to find something that works, right? Combining with the fact that x squared plus y squared, we know that's to be 5 from the second equation here. I should be able to solve for xy. All right, so I know that negative 2xy plus x squared plus y squared, that's 5. That should give me 16. And from here, I should get that xy is equal to negative 11 over 2. And that's pretty good because now that we have negative 11 over 2 for xy, we can directly substitute everything now, right? We know that x minus y is 4, right? And then we know that x squared plus y squared over here, that's going to become 5. And then we know that xy here is negative 11 over 2. So plus negative 11 over 2, which is just essentially minus 11 over 2 here. Now, 5 minus 11 over 2, this part is negative 1 half. 4 times negative 1 half, we're going to get the answer here to be negative 2, right? So that's for the first one. Now, next, let's try to do an item from just the recently concluded qualifying stage of the 24th PMO. Let omega not equal to 1 be a complex root of x cubed plus 1 equals 0. What is the value of 1 plus 2 omega plus 3 omega squared plus 4 omega cubed plus 5 omega to the 4th? All right, now we can do some algebraic manipulation here because we know that omega is a root to this equation. So obviously I would get that I could substitute omega in and it should be correct since it's a root to the equation. So I would know that omega cubed plus 1 would be equal to 0. And that's going to give me a nice omega cubed is equal to negative 1. And that's going to allow me to simplify this to the 4 omega cubed and the 5 omega to the 4th, which is pretty good. So since I know that omega cubed, that's going to be equal to negative 1. So the 4 omega cubed, I could just make it 4 times negative 1. And then the 5 omega to the 4th, I'll make it 5 omega times negative 1. So using this fact. So essentially, I would just have to get the value of, well, 1 plus 2 omega plus 3 omega squared minus 4 minus 5 omega. So just combine the like terms. It's going to be 3 omega squared minus 3 omega, then a minus 3. Right, so we need this one. And let's try to dig deeper into this one. Since it is a sum of two cubes, and well, there's no way I could get this one without getting omega. So let's try to take a look at this one. We know it's factorable, and we technically haven't used the omega not equal to -1 condition. So if I were to factor the left-hand side, I'll get x plus 1 times x squared minus x plus 1. And that's going to be equal to 0. And I think this is where the omega factor comes in because, well, obviously I could substitute x as omega and it should work. So I would know that omega plus 1 times omega squared minus omega plus 1, that's going to be equal to 0. And because of this nice condition that omega is not equal to -1, I could divide both sides by omega plus 1. Or essentially I could cancel the omega plus 1 over here because omega is not equal to 1. So I'm sure that I'm not dividing by 0. And that is good for us because we're going to have this nice condition that omega squared minus omega plus 1 is equal to 0. And that's going to give me omega squared minus omega is equal to -1. And that's going to be the last piece of our puzzle here because we do realize that I could factor a 3 here. And it's going to be 3 times omega squared minus omega. And a minus 3 here on the outside. And because of the nice condition that omega squared minus omega is -1, omega squared minus omega here, I could replace it with -1. 3 times -1, that's -3. Subtracting 3, I'm going to get -6, right? So I could potentially get omega actually, but we don't really have to do that because of the nice work we've done in the algebraic manipulation. All right, I'll show you guys another one from the 22nd PMO. This has logarithms, which is weird in the first place, but I'll just kind of show you the rough outline. You guys could try to finish up the solution. All right. Now, it is pretty weird that we do have logarithms. So what's the connection of like algebraic manipulation to logarithms? Well, we do have nice properties in logarithms. Now take a look at this part, the thing that we're getting. We know that there is a property that this part, we can write this as logarithm of x with base 2 plus the logarithm of y with base 2. Okay. And I could tell you guys that these two equations, we could kind of manipulate it via the change of base formula. All right. So it's already on the screen over here. That's pretty much the manipulation we could do. Let's involve some more properties. Again, whenever we have these types of questions, there isn't really a nice standard way for us to do it. It's just us trying to do the manipulation, trying to find some creative ways to answer the question. Now in this case, well, there is the squared in the two terms over here. Let me bring it to the front. And essentially, I believe this would become a system of linear equations because I think what I could do here is maybe I would want to make the substitution here. For example, maybe I want to make log x with base 2 to be a, log y with base 2 to be b. So essentially, it's going to be like a system of equations. You could try to solve for a and b. And going back to this part, essentially, I would get a, and I would get this to be, I would get b from the system of equations, get them, add them up, and essentially that's going to be your answer. And that's because of like just some nice manipulations. All right. So you guys could try to work out what the values of log x and log x with base 2 and log y with base 2 are, and you guys should be able to get that the answer here, it's going to be equal to 16. That wraps up the episode on algebraic manipulation. Hopefully you guys learned something new here. I'll see you again next time. Bye-bye.
The Mathematical Society of the Philippines is the country's premier professional organization dedicated to the promotion of mathematics research and education in the country. Founded in 1973, it has grown from a small Manila-based group of math educators to a nationwide network of individuals with chapters all over the country. The Philippine Mathematical Olympiad is organized by the Mathematical Society of the Philippines in partnership with the Department of Science and Technology Science Education Institute. The 24th PMO will be held online in 2 stages, the qualifying stage in February 2022 and the national stage in March 2022. The start of the registration is January 2022. More details are in our Facebook page and also in our webpage, pmo.ph.